We're looking at proportional reasoning, and the method we're going to use to solve this question is by graphing. The overall expectation is to solve problems involving proportional reasoning, and the specific expectation solve problems involving ratios, rates, and directly proportional relationships in various contexts. And we're going to use dynamic software to construct and measure. So here's our question. We're going to read through it once, and then we're going to highlight what's important. The table below shows the cost of water for 3 different customers. They each pay the same cost per liter, so here's our table. Gabriel pays $46 for water at the same rate. Determine the number of liters of water that he purchased. So let's read this again. The table below shows the cost of water for 3 different customers. Okay, they each pay the same cost per liter. That's important. Gabriel pays $46 for the water at the same rate that these customers did, and determine the number of liters of water that he purchased. Okay, so on our table we have our customers. We'll call them 1, customer 2, and customer 3. As you'll notice, the measurement they've used is cost per liter. Okay, and that makes sense because it looks like what's happening here is depending on the amount of liters we purchase, our costs will change, which means that this is our independent variable and this is our dependent variable. Which means if we're going to be doing graphing, this will be our x-axis and this will be our y-axis. Okay, now in order to graph this, it'll actually help if we could take these each as a set of coordinates, right? We could plot these out as coordinates and then kind of continue our graph from there and then find our graph, which is, it's definitely doable. Another thing we're going to do is we're actually going to try to construct the formula for the graph and then plug it into our software. Okay, so because all of these customers actually pay the exact same rate, it doesn't matter which customer we use. So this is what we'll do. We're going to set up our liters and our dollars. Okay, and we'll use customer 2's values. Customer 2 had 20,000 liters of water, and they paid a rate of $18.40. Because it's cost per liter here, okay, that's our cost per liter, we're going to build a relationship where our y, like we said, is our money, and our x variable is our cost. So we have a directly proportional relationship, which means if we're going to build an equation, it's going to look like this. We're going to have y is equal to m, which is our rate, times x. Okay, and actually we'll color these to help us out. So we know our dollar value is our y, and we know that our liters are our x. We have to find the cost per liter. So because it's a cost per liter, okay, we need to bring down the liters to the value of 1. So we need liters to be the number 1. So we need to do something that will reduce this relationship from 20,000 to the number 1. Well, I know if I divide 20,000 by 20,000, okay, that'll bring my liters down to 1. Whatever I do the liters, I have to do my dollar value also. So I'll need to divide 1840 by 20,000 also. Okay, this number here, this will be our rate. It'll be equal to our m value. So let's take out our calculator here. We're going to take $18.40 and divide it by our 20,000. And we get decimal followed by 3 zeros, and the number is 92. So our rate is 0.00092. So we write our little equation here. We have y is equal to, we'll replace m with 0.00092 x. Okay, this will help out a lot. So we're going to put this into our dynamic software, and we're going to solve for our $46 of water. Okay, so here's my software, and I plugged in my equation, y equals 0.0002 or 92 times x. And we have a very straight line, and it's hard to see. We need to set up our graph scale. Okay, so I'm going to affect the scale of the graph. Remember, the x-axis is representing our liters. So we know our liters go from 0, and the values we were using, if we go back, were 10,000, 20, 30. We don't really know how high they're going to go. And so we're going to make it relatively large, maybe even up to 80,000. Okay. Our y-axis, on the other hand, goes from 920. We know we kind of max out at 46, so I'll just go to 50. So we know 0 is the lowest amount, and our y. Okay. So here's our axis now, and I can kind of pull it down just a little so we can see our numbers. Here we start at 0, and here's 10,000, and we know at 10,000 they paid $9, 9.2, 20 cents. This is great. What we need is to figure out at $46, okay? So in other words, that's some value up here, and I could just kind of run along this if I want to see. There's 42, 43, okay? But it'll actually probably be a lot more helpful if I do something like this and use a point of intersection, y equals 46, okay? And where y equals 46, this is exactly where these two lines meet. Our y value is $46, and it looks like the x value is 50,000, which is exactly how many liters Gabriel purchased. So we can write down that we know, we'll just kind of continue our table here, that Gabriel paid $46, and for $46, he got 50,000 liters, okay? If you'd like to see other ways to solve this question, you can check out our other playlists on proportional reasoning.